IoT Asia for this invitation to speak. I'd like to thank them for giving me my topic, which was as you're going to be at the end, could you bring it all together? I'd also like to thank some of my previous speakers because there's some information you're going to see again because it came from Cisco originally. But the other thing you'll see is there will not be too much difference. Was that model. A lot of the communications there were all about SMS and other derivatives, but very much driving towards IP. The industry echo was the Internet of Things. The Internet of Things went broader than just those things out of the mobility market, and you'll see that they could be tethered or wireless, and there are other wireless protocols involved and standards other than just telephony standards. Cisco believes that the Internet of Things will be very much IP-based, you'll see in my theme. And then what we introduced was a thing called the Internet of Everything. So they're a bit like these Russian dolls. The messages go inside one another, and the overlap is a bigger message. But what is the Internet of Everything? I tried to put this on one slide to bring it all together. It is the intersection of people, things, processes, and data. Just technology by itself doesn't do that much. It's just to focus on data alone without an underlying capability of how it integrates won't do much. It's all those things gathered together. We've seen countless different scenarios this morning about what that looks like. But perhaps it can look like sensors going out that can determine the difference between pollution counts and pollen counts. Information that's analysed that gives real-time information maybe to a hospital to say, expect this type of people to show up with these types of symptoms. Even more important as it comes together might be the ability to identify those people and tell them about what's happening in various parts of the city, whether to stay indoors or places where it might be easier or better for them to go. Seen this slide before. I'm not going to talk about the volume. The volumes are big. That's not the issue. It's about things connected to the internet. And the internet is a euphemism for not just the internet, the big I internet. It's all those networks that come together that federate as a network of networks in the ultimate internet itself. What I'm going to talk about is the slope of that curve. That's more important to us. What you'll see is where markets move this quick, there are a lot of people come in, there's a lot of people come to do things. What we end up having, and it doesn't matter whichever technology you end up with, is competing systems, people that want to be the leader. I want to get access to all that. I want to own all that. I want to deliver it all. Now, I'm going to show you what we believe are the platform capabilities going forward. And what the problem with this curve is we don't have much time. We don't have much time to get it right, and there is a lot to get right, as you'll see as I move through my presentation. All industries are affected. And right at the moment, we're in a mode where we're about connecting people and consumerism and the consumerization of IT, driven their cloud technologies and the like. The Internet of Things and Internet of Everything is driven from a different wave. It's a wave going back, touching the enterprise and operation technologies. What I'm seeing from some of our larger customers is they're even reorganizing themselves. They're no longer OT and IT separated from one another. They're now combining into one organization because they know they have to go across this boundary. And it's going to happen for all industries. So combined names, you'll hear terms like information management rather than IT or OT. It's true from other speakers that said we've been here before. There are many, many things connected. There's a lot of things out there. The problem with them, the model that was used was there were ample standards, ample mechanisms, multiple deployments, and they typically were stranded. And the problem there was We have to move from a model where things talk for a specific function, optimized for one thing. And we want this concept of analysis to get, like that example I talked about with pollution counts. I want to get multiple outcomes. For that to occur, I've got to move from a model of more closed systems and limited gateways to more federated systems, where systems and devices freely interconnect, get more outcome inside its silo, but then federate these together in ever higher and more federated networks of information, systems, data, people, devices, to get other outcomes. And so I'm going to put some names to some of the trends and things that other speakers have talked about. And what we'll do is we'll talk about the architectures, because that's largely what I am. I'm a network architect. So this is the underlying architect that's happening in the industry right at the moment. The move towards centralized computing, cloud computing models, connecting devices, which are largely human-centric, into a compute model where we move compute, storage, and information and applications centrally, and we deliver them. We do this because these worlds are complex. Many IT departments can't do these, and we need new monetization models, as you've seen before, where people are no longer selling their machines, they're renting their outcome, right? So this is IT's current model, but it's based on some interesting concepts. This concept of infinite bandwidth and zero delay. You may not be following, but many of the large data center suppliers, the cloud suppliers, are putting their data centers within 3,000 kilometers of their end target customers. They need to do that because the latency that occurs beyond that means certain classes of applications deployed in this world just won't work. And we'll see these models echo as we move into structures for IoT. Infinite bandwidth? Well, yes. We talked about the fibre here interconnecting in Singapore and terrestrial infrastructures. And we talk about the internet growing and keeping pace with that growth in the core. Now that's going to continue, and the IoT and IoE world will contribute to that tremendously moving forward and change the models of communication flows from more a north-south centric communication flow to an east-west centric communication flows, devices and people and things talk to one another. But the problem we have here is what happens when we move to IoT? Well, there's some things that happen. Speed of light comes in again. But I'm not talking thousands of kilometres. I'm talking kilometres, thousands of metres. We may need to make decisions which are latency critical, where responsiveness is critical to the event and the outcome that we wish to achieve. We're not going to put things in a cloud model 3,000 kilometres away. We need to bring that compute closer. And you heard from others that spoke before me about this concept of bringing this compute, bringing this analytics closer. Resiliency. Well, you know, we all live on the internet. It's amazing that sometimes it works at all, but it is quite reliable and jeopardises models of other tethered information infrastructure, wide area network technology. But what of the resiliency we need to talk about here is when we start talking about sensors, sensor grids, we're talking about wireless communications. Now, wireless communications is very varied, and when we need to rely on it for certain outcomes, we need to build systems that are more resilient in a lossy information connectivity world. Security. Previous speaker from Intel talked about this, and I've dedicated a whole part to security because I believe it is the one big challenge that we have when we build things beyond the billions into size, about how do we keep it secure? How do we go about that? And of course, the last one, data grows faster than bandwidth. We heard it from the analysis from SAP this morning about the truck. That was a logistics truck. I work with some mining. A Caterpillar dump truck, one of those large things, has over 200 sensors on it, similar. It also, those sensors deploy at 40 milliseconds per sensor data item. The concept that we can move all that data centrally into a cloud model will not work. We need another model. Oh, and by the way, that's only one of 5 networks. That's telemetry. They also have video. They also have fatigue management systems. And none of those trucks are autonomous. So those trucks need to tell one another about where they are in space and time, because they're hundreds of tons in weight. So what's the model? I'm going to introduce a concept called, we've all heard about cloud computing. I'm going to introduce a concept called fog computing. And this is the term that academia has put on bringing this concept to moving the compute model to distributed intelligence closer to where the sensor grids, the actuators and control systems live. So we'll introduce this concept of a model in infrastructure that assumes limited bandwidth, expects variable delay, expects loss, and we build protocols and systems on top of that to accommodate and to work in that environment. We distribute that intelligence in the field. It doesn't mean that we're not going to use the cloud. The cloud's still there. We're going to have analytics closer, and we're going to have analytics at a federated system deeper into the fabric. And of course, we need those cloud systems to deliver those contexts and contact to the humans, where we talk about that device-human interaction at that summarization level. So fog computing is a newer model that's come into the market, and we're going to start seeing a lot more distributed intelligence and a lot more platforms moving forward to enable that to occur. We believe that a lot of what happens in fog and going north will be based on open standards protocols, IP and internet technologies in particular. We'll do that because we ensure interoperability and reduce technology risk. And that's important because remember the slope of that curve? We're moving so fast, we don't have time to go and reinvent platforms. People will, but we fully expect that they will die over time or be challenged, be run down by that open systems environment. So here you see some, I couldn't put them all, I just put some of the standards bodies that are involved, and they're the obvious players. But that doesn't mean that everything won't be standard everywhere. Of course, invention has to happen where the internet doesn't invent. There may be technologies, protocols that need to be invented, especially when we expect it in the sensor grid. So it's at that fog layer that, where we will do adoption from one protocol that's further down, maybe perhaps in the sensor and actuator grids, and then we'll come back to internet technologies north of the fog. So here's an example of a protocol stack. This happens to be a smart grid deployment. Here you see a pole top router. Here are all the different types of protocols in the communication stacks, which are open standards that enable that to occur. I'll run you through some. Different link layers. 802.15, wireless standard. We see underpin Zigbee, wireless HART in the industrial automation environments. We'll see data over power line happen that is needed for this environment. New protocols, adaptation layer, 6LoWPAN, IPv6 over low power, lossy infrastructure. We can't rely on other protocols. We have to have protocols specifically to work into this fog computing model where we have variable delay and lossy infrastructure. You'll see another protocol there called RPL, pronounced Ripple. In a sensor grid, we have a pole top router, comes to the top of the street, sees the meter in your house, but it cannot reach over this wireless infrastructure to the next house or the next house. Or maybe from the smart power meter utility to the gas meter or the water meter. Ripple is a protocol that enables these meters to interchange through a mesh and self-heal in the event that there is a hole that will create a mechanism, a communications fabric, where I can send low volume messages between any device through a ripple effect through a local field bus. CoAP, CoAP. We can't take the very, very large industrial strength web services protocols that we use in the internet on big iron PCs. Sounds a lot for desktop PCs to be big iron, or even on devices. We are now talking about very low power, very low compute environments. You'll see even our web services protocols are being adapted, and CoAP is one of those that enables us to get down to smaller, simpler forms of messaging that's required, especially in these sensor grids environments. And lastly, down the bottom there, I'm giving you just an example of some of the protocols on security. First one, datagram, transport level security. We're not going to be sending large files. We may send files from time to time, bootload, new images, information, but we're going to send a lot of small pieces of information. We need datagrams that are secure. 802.1 AR, this is called device ID. One of the very first problems of securing an environment is, how do I identify what it is, and is it what it says? There is a standard for that. 802.1x, if I have this appliance or this device and I now bring it into the network, how do I authenticate it to the network itself? Is it one of mine? Does it need to come on? How do I do that? So a lot of these protocols and standards are there to help build on this, and it's this wealth of protocol stack in the open standards communities which will dictate very much that people who are really centered on the outcomes, think of it like the Apple world. People are interested in building the applications. I wanted to build the application. I didn't want to build the platform on which it ran. So open systems protocols will dominate this world. Security. Well, we're going to adopt internet technologies. The bad side of that is, with adopting internet technologies comes internet's problems. And the biggest problem in the internet is security. So what you're going to see is a lot of work that's going to leverage out of those open standards protocols and systems to try and put security into a model which takes it into a whole new level. We have devices out there which need to be protected, not because they can't protect themselves. So there's a new model for how we're going to deploy this. So I've listed some of these points down here. I'm not going to run through them, but I'm going to list 4 main areas where we can see that this is where the focus will be. The first will be, we'll move from device-centric security models. We can't set policy that says that this sensor talks to this one other thing, because we now might make it talk to a lot of different things. In security, you'll see role-based access happen. We might be able to say these groups of sensors represent this community, and this community can talk to these things, but not these other things. It's going to be a different way by which we address security to be able to enforce policy at such a distributed level. The next one might be the obvious. We've got these devices, they're out there, and they are exposed. The platforms on which they're deployed need to be anti-tamper proof, definitely physically, environmentally hardened, IP67, but they also have to be anti-tamper proof, and also when compromised, we need to be able to detect it and then take action. So a lot more work done there. Data protection and confidentiality goes without mentioning, but more so when we talk about sensor grids, where we picked about people. I mean, I too have a Fitbit, right? But I don't want that information going to anyone other than my daughter, who taunts me. Especially as we move into health and other sensitive relations. The infrastructures on which these runs and the devices and the whole federation of that communications must be secure. And lastly, the infrastructure. As we move the internet out into the periphery across a wide coverage, we need to be able to protect the infrastructure from denial of service attacks or from masquerading events where someone else will come on and try and masquerade to be something which it is not, and take over these infrastructures as we depend and rely upon them. So one of the building blocks we'll see is the emergence of platforms. Software embedded systems on open platforms, running open standard software and software development kits with APIs that let people focus on the application and the function they want to do. And these aren't necessarily small players. These are some of the largest players in the industry who say, I want to build those. I want to build and focus on what I do well, and I want to be able to run on platforms. I want other people to provide these other capabilities for me. So we'll see a lot of that. We'll also see something more interesting, and when done right, we may actually see them as multi-tenanted platforms, where the infrastructure could be owned by a service provider, and by that I mean in the widest sense, where multiple applications run on one platform from different vendors that are totally protected and secured and isolated, that would let multiple outcomes happen in an area without having to deploy multiple levels of gateways or multiple levels of distributed fog compute platforms. Oh, that is an example of that same pole-top router. The software needs to be able to run in something like that, or it needs to be able to run embedded in the actual meter itself. Multiple ways. And there's not one solution fits all. It's not possible. Lastly, there's another big factor here, which no one has mentioned, is there's a big role for governments. Governments need to be there, especially when we get out into spectrum management, to manage that spectrum that we're going to need in these wireless field area networks that let us be able to attach to these distributed environments. We need legislation to keep pace. Now, legislation has never been able to keep pace with internet in the past. And I've just showed you that the slope of that curve is faster than it ever has been before. We really, really need governments to start looking at privacy, security, and governance models for the deployment and catch up with them now rather than play retrospective catch up later and perhaps be part of the problem. Standardization goes without saying. Everything I've talked about has been standardized for open systems, platforms, software and the like. But there's also other forms of standardization, especially when we go beyond the fog computing into the commercial, into the consumer world. And the best example I can give here, following on from the smart grid solution, many people talk about smart grids as meter reading, but smart grids can go further than that. A smart grid might be able to say, I'm coming up as a utility, I have a discretionary load I need to get rid of. I can do it as I could in the past. I could black out a suburb. I could black out a circuit that I predefined. Now we can do that on current analog technology. But once we get to the point where we have standards that link between our fog networks and our high power utilization, such as our air conditioners in our warm climates or our furnaces in our cold climates, perhaps I can do something a little bit more interesting. I could change the temperature and override the temperature rather than turn it off completely, and therefore meet my power threshold that I need in the market. Now, for that to occur, especially when we get into automotive and consumer devices, we need governments to help set those standards that lets industry develop towards to get the outcome that we want. Education goes without fail. We need governments to sit there and educate and bring on the next generation. And we saw that earlier today. But that's too late. That curve is in play. We cannot afford to continue to build things the way we did before because we are spending precious money on infrastructure today. Bridges, rail, airports, they're all in play today. We can't wait for those 12 and 8-year-olds with robotics to come through. We have to be able to educate a field where this technology is changing very quickly, and governments and industry has a part to play here. And lastly, incubator funding. Every country has some industries which it leads in. And there's a part to play here where the government stands up and actually takes an active role. I was very encouraged to see what Singapore is doing to try and incubate and encourage what's happening in the Internet of Things. It is important to do those inside the industries and technologies which you're in. In Australia, we'll most probably not be a massive manufacturing base, but we may do it in agriculture and we may do it in mining. Every country should look at what it's good at and lead in those areas. It's the betterment of their own citizens and also the betterment and improvement of how this technology gets adapted. Yes, the famous 99%. Someone said to me, when you're up here, could you please tell me, what does the future look like? And I have no better comment or quote than from this chap here. Professor Michael Nelson of Georgetown University said, trying to determine the market size of the internet is like trying to calculate the market size for plastics circa 1940. At that time, it was difficult to imagine that plastics would be in everything. And that's about where we are today, right? We do have things that are connected, and we do have process control systems. They're just not federated in a way or open enough that lets us get the value that we seek. And all the things that could be connected, we don't know what they are. And they're all before us. And I'd like one correction. The 14.4 trillion, these numbers came from Cisco's business consulting division. We went out and analysed different industries and different use cases. came up with the magic number of $19 trillion because many people focus on the commercial component. And that's the 14.4 trillion. There's a very large component of public sector productivity gain to happen in this world as well. Right? That's the 4.6. And so what I'll leave you with is the interesting component is my sons and daughter grew up with the internet. They just expect it to be there. There's very few times in your life you actually get to live, feel, contribute, and maybe contribute to the betterment thereof of a major wave of technology coming through. The Internet of Things, the Internet of Everything is happening now in our lifetime and my children's lifetime, and we're right at the beginning of it. It will be a very interesting time. Thank you.
Good morning. As stated, one, thank you to the IoT Asia organization for giving Intel the opportunity to present to the audience. 20 minutes is not a lot of time, and I'm going to do my best to get through the content and make sure we finish in a timely manner. We have found this assessment of how the Internet of Things world will evolve over the balance of the decade to be extremely insightful. It begins to paint the premise for which most of us will have to evolve as companies, as businesses, and as consumers through the balance of the decade. So as we move from essentially being largely aware of a mobile world and learning how to work and operate on a mobile world, and we deal with the implications of an always-on life, and in fact, as we look at the new generation of managers and even children, what we're seeing is a completely different level of connected awareness and connected requirement that will be then fueled by the ability to drive this all into cloud applications and cloud environments, together with a sensor economy that will grow rather substantially through the second half of the decade, leading to a truly enabled Internet of Things, ubiquity in terms of our ability to connect and to be managed through a number of things together with cloud capabilities, cloud services, in a connected business, eventually becoming a semantic environment where devices self-configure, devices are self-aware, devices become artificially intelligent and become self-programming and self-provisioning. And we see the key to this, though, is that these types of capabilities are actually, from our point of view, things that are required in order to survive as a business through the balance of this year. So as we go forward, we're going to talk more about how specific technologies come together to enable this world. Internet of Things isn't new. I think probably one of the most interesting things as we all begin to work through the market is that we begin to believe, or at least think, Internet of Things is a new concept. Actually, you know, from an Intel perspective, we've been connecting devices. Our colleagues from Bosch and SAP and others that have presented to you this morning, we've been connecting devices for decades. It's not new. What is new, though, is the idea that we can derive substantial benefit from the use of data through the mining of data and through the analytics and business intelligence that can be gathered through data. And as we work today dealing with all these different segments and all these different markets, you know, you've heard the use cases again and again and again that are all rather similar or all rather cohesive in terms of this idea of taking appliances that are loaded with sensors, extracting the data from those appliances and putting them into analytics frameworks that then drive some level of value. And we're going to talk more about how that value gets derived and what the critical factors around them should be. Our vision of IoT is rather simple, actually. It's about how we take computing and communications technology, drive them into ubiquity such that they become almost indistinguishable from the surroundings themselves, that the ability to extract data, throw that data into analytics frameworks and allow deep contextual experiences that are actually meaningful to the users or to the businesses in which the data and analytics is being derived is critical. The bottom line is that we have to do this in such a way in order to drive true ubiquity. When you start talking about, I don't care if it's 15 billion, 20 billion, 50 billion, 200 billion, I've heard every single number there is, or whether it's trillions of dollars, as in the case of Cisco with their value at stake at 14 trillion, or you talk about GE's assumption with World Bank that it's half the global domestic product of 32 trillion. When you talk B's and T's on the end of numbers, it's huge. And to drive true ubiquity, you've got to make the technology extremely interoperable. Going on a forward basis to look at this is something where we can continue to exist in silos of automation or silos of opportunity in terms of different systems, different capabilities. We really have to drive to a point where these things become interoperable, and we make the technology essentially disappear, make the technology almost irrelevant, and drive up the value in terms of the context that's delivered and the business intelligence and the business value that's derived from these technologies. Internet of Things is going to be comprised really of three key elements to us. How we take smart devices, combine them, and integrate them into things that drive secure systems of systems. And I'm going to talk about security quite a bit. I've listened to a number of presentations this morning. Security tends not to be the thing that people talk about most, but it's fundamental. The bottom line is, if you can't trust the source of your data, if you can't trust the content that's being delivered to your analytics engines, by definition, any decisions you make off that data are essentially invalid. And so for us as Intel and for our partners, what we're learning again and again as we go out and we talk about all the different use cases and all the different vertical industries, that getting to the point where these systems are secure is critical. And once they're secure, we can then drive the ability to really put in trustworthy end-to-end analytics. And in building smart devices that become secure systems of systems that then drive end-to-end analytics across the entire frame of the application segment is when we start to see true value. People talk about IoT, and maybe we're a little bit too mercenary, but at the end of the day, for us, IoT is about turning data into money. If we're not collecting data for a purpose, collecting data for the sake of collecting data is irrelevant. If we can't turn data into revenue through data mining, or we can't turn data into improved operations and therefore profitability, then at the end of the day, there's really no value in IoT. And so for us, what we believe is that if you can securely manage data and assets, essentially track, command, control, optimize, and monetize assets and data, then you're truly capitalizing on the opportunity in Internet of Things. And for us, there's basic capabilities that need to be pulled together in order for this promise of Internet of Things to be fully realized. We use a simple definition. Billions of things, but that are connected. We call these appliances, the things at the deep edge that are sensor-enabled technologies that are basically producing data. And I'll talk more about the hierarchical structure and systems of systems in a second. But bottom line is, we believe the highlighted yellow elements of this chart to be table stakes. If as businesses, as communities, as governments, as enterprise, whatever the case may be, if you are not understanding how to pull together the ability to connect these appliances, manage these appliances, and secure these appliances over networks, you're probably not going to be part of that evolution that Booz & Company talks about over the balance of the decade. In fact, and as I said, it's not about just being able to connect, manage, and secure appliances. It's really about how you intelligently extract data, turn that data into actionable information through analytics and business intelligence, and then drive valued services. Valued services is critical. We've been talking about this for in excess of 2.5 years. And that is, again, back to this idea, if you can't drive revenue and profit from this construct, then the system by definition is faulted in what its true value is from an economic standpoint or from a business standpoint. So this is all about delivering revenue and profit and doing so from actionable information from valued services. From an IoT systems of systems perspective, we look at these things as a scaled construct of interoperable platforms that are secured from point to point. This construct of hierarchical systems, we find it to be very common in all IoT applications. I've listened with interest to folks this morning talk about the different applications, but they all have something in common. That common element, that opportunity for ubiquity, is in taking sensors and controllers that are buried deep inside every appliance that gets built these days, and therefore creating and presenting the opportunity for us to react to a real-world environment. Being able to acquire that data off those appliances, aggregate it, prepare it for presentations to analytics frameworks, and then deliver it to those analytics frameworks, which we believe are fundamentally constructed in the cloud. And understanding that given the amount of data we're going to produce, that driving everything to the cloud itself is probably an unrealistic expectation. Edge devices must be able, these edge appliances, these edge technologies need to be able to be cloud-like in their instantiation. They need to be able to filter data at the edge. They need to be able to run analytics. They need to be able to do the things that a data center would do, but do it on a reduced and purposeful basis. And then once you've moved the data into the cloud where you store it, you apply analytics to it, you apply intelligence to it, and you basically build decisions and policies from it, you need to be able to either drive it back down into those edge and sensor control-based appliances, which is machine to machine, or you need to allow users to interact with it, which is the client technologies that get driven at the end. At the end of the day, these systems need to be scalable, secure, and interoperable, and these things are hierarchical. They're not something where it's just one thing that you deploy and that thing is going to be out there and it's going to be able to provide you this environment of Internet of Things. This is a scaled set of systems that are hierarchical one to the next and deliver truly interoperable capability. So what we're doing from a transformation standpoint is we're trying to move from sort of the past where we've had these fixed function isolated technologies that then we figured out how to network those technologies together. Again, we've been doing this for decades. But the key is, how do you actually begin to drive data over function? How do you begin to look at these things as being interoperable technologies and being served through a central construct like cloud infrastructure and cloud-based analytics and decision systems that are securely interoperable? And you notice I've said this again and again, security and interoperable in our view are two elements which are almost inescapable. If we can drive to that point of data over function with interoperable security, we believe that truly enables a world of big data analytics where multiple sources can be delivered to a central analytics construct in which you're now able to perform meaningful data analytics and deliver true business intelligence to the market. So, as I said, billions and trillions, it's a transformational opportunity. One interesting note is, and I took a slide out of my deck, which I think is actually fairly instructive, and that is that the rate of data growth will exceed the rate of our ability to store it by almost 5 times. And based on that, these dreams of having all these small little appliances that are somehow wirelessly enabled and connecting into cloud infrastructure, delivering wonderful context, probably is unrealistic given the fact that we really have to do, we should be using the data center, the big iron data analytics capabilities to provide deep context from multiple sources and then allow edge analytics and edge devices, to drive the true transformational opportunity in terms of local control, local analytics, local management, much closer to the sensor where we derive much higher value and much more benefit. So the key is, how do we enable a framework that really simplifies the Internet of Things and actually maximizes data value so that we can see the resulting opportunities delivered that truly result in services driving revenue and profit. So again, we believe that if you want the path to trillions, in revenue and profit, which everybody portends for the market, if we can't deliver secure interoperability that unlocks the value of edge data and drives it into analytics frameworks, we're simply probably underselling or undercapitalizing on the opportunity that exists in front of us. So securing and simplifying the Internet of Things is really critical. Intel actually believes that the opportunity will be derived initially from legacy systems that are already deployed in the market. I've watched with interest, again, all the presentations that have been given today. And what we're talking about is how do you instrument things that are already out there? I think Cisco has claimed that 99% of the things to be connected are yet to be connected, that they are still to be connected over the balance of the decade. We've looked at it and concluded that 85% of the things to be connected over the balance of the decade are things that are already in service. They've already been deployed, they're already operational, they're already producing data, they're already part of a networked construct. And so, being able to actually bring those deployed assets, high-value assets, into a 21st century data analytics environment, and doing so through bolt-on technologies, things that we can rapidly deploy into existing environments that actually allow us to bring the brownfield, the things already deployed into services capabilities, combined with data flow, unlocks the massive opportunity for services. And actually, when we look at the data flow opportunities that we're seeing, what we're actually learning as we go through this is that large numbers of the opportunities have to do around the very things that have been talked about repeatedly today. Predictive analytics, preventative maintenance, prescriptive analytics, bringing technologies and products that are deployed into service frameworks that reduce operational costs, improve service capabilities, and improve service efficiency. These opportunities again and again come back as the common themes in the market, and that's where we see initial services being deployed. As I've said, security is absolutely fundamental to this, and as we look at it, to secure big data, it's just not a matter of being able to have data centers that are secure using traditional blacklisting and signature-based malware and threat detection type software. You really need to secure it end to end. You need to be able to ensure that the root of data extraction is actually trustworthy and that the devices moving the data off these appliances is trustworthy as well. So you'll see Intel focus on the big four areas here, which is an end-to-end common security standard, which will be broadly deployed across all of our enabled products and technologies with our partners that not only enable the deep edge in terms of the user and intelligent device end of the spectrum, but also the data center and client technologies that feed off these end-use devices, securing big data through the entire construct. One of the big things that we believe is instrumental when I talked about that edge environment is when you take the security element and now you build it into what we see as the next big platform for the Internet of Things, which is the intelligent gateway, the device that allows you to go to a legacy install base attached directly to that legacy install base through legacy networks and legacy communications protocols, pull the data off those appliances and drive it into the analytics framework. We've actually begun to build and try to make as simple as we've made the PC as a deployable technology, the Internet of Things gateway as the connecting tissue between existing deployed assets and cloud-based analytics. So you'll see us, we have already announced that we are making available to the market through partner relationships what we're calling intelligent services gateways that will actually allow a family of devices that will be scalable based on processing technology, allow us to actually address the increasing requirements of complex analytics and to do so seamlessly. That actually protects the value and the investment you make in your software, which is critical. Being able to scale analytics across an increasing base of technical processing technologies that is integrated with security and fundamental operating system software and middleware that's completely open in its architecture. We don't believe that this market grows through proprietary isolated technologies, that these systems must be open and freely available to the market, and that these will ensure, and through this, open up the services market and services opportunity that in turn allows for the applications and the services and the analytics to be deployed seamlessly across a very broad base of market architecture. So what you'll see, rather simplistic drawing, if you go back to my idea of a vertically built structure of technologies, the gateway for us is an open systems platform that is multi-vertical in its construct, allows us to address all of the industries equally, is enabled with unique software based on vertical context, but then allows us to connect up to cloud and analytic technologies, but allows us to also connect down into the appliances and seamlessly move data back and forth between those two constructs in an open systems, fully programmable, fully operational mode that is fully secured and allows for local decision-making, local analytics, and local programmability. We look at this as really enabling us and the industry to drive that ubiquity that I talked about earlier in the presentation in terms of addressing endless use cases and being able to not only enable deployed assets, but also new greenfield assets that would be designed with this technology, again, fully enabled with security and the capabilities around the market. So our approach is going to be very centered on IoT gateways, tying these gateways into cloud infrastructure, data center technology, security infrastructure, and doing that together with the assets that we've been able to put together within the company. So with that, it's 000 on the clock, 20 minutes. And I appreciate your attention and all the pictures. Hopefully, if we have an opportunity to interact through the day, we'll get that chance. Thank you for your attention and time.